Hello everyone, welcome to the Code with AI channel. In this series, we are going to learn Python programming from absolute beginner level. So if you have never done programming before, don't worry at all. This series is specially made for beginners. Also, in this first episode, we will not write any code yet. Instead, we will focus on understanding the basic concepts that every programmer should know before starting. By the end of this video, you will understand what a programming language is, what Python is, and some important concepts like variables and data types. So let's start with the most basic question. What is a programming language? Ever wondered what makes your phone, computer, and even your car work? A programming language is simply a way to give instructions to a computer so it can perform tasks. For example, when you open a website, play a game, or use an app on your phone, there is code running behind the scenes. Developers write that code using programming languages. Some popular programming languages include Java, C++, JavaScript, and Python. Each has its own strengths. Java is used for many enterprise apps, C++ for games, JavaScript for the web, and Python for data science. Each language has its own syntax and use cases, but their main goal is the same: to tell computers what to do. Programming is the language of the future. Ready to learn more? Imagine you want a computer to calculate the sum of two numbers. Instead of doing the math yourself, you can write a small program that tells the computer how to do it. The computer reads your instructions step by step and produces the result. So in simple words, programming is the process of writing instructions for computers using a programming language. Now that we understand what programming languages are, let's talk about one of the most popular ones in the world, Python. Python is a high-level programming language that was created by Guido van Rossum and first released in 1991. One of the main reasons Python became so popular is because it is simple and easy to read. Its syntax is very close to plain English, which makes it perfect for beginners. Because of its simplicity and power, Python is widely used in many industries. Python is one of the most versatile languages today. It's used in countless fields, making it essential for any developer. In web development, Python powers complex backends. It's also the backbone of artificial intelligence and machine learning. Data scientists use Python to analyze massive datasets, while its automation capabilities handle repetitive tasks with ease. Even game development uses Python for scripting and prototyping. It truly is a language that can do it all. Tech giants like Google, Netflix, and Instagram rely on Python to serve content to billions of users daily. Now that we've seen Python's power, let's dive into our first concept: variables. Ready? Let's get started. A variable is essentially a way to store data so your code can remember it later. You can think of a variable as a container or a box that holds information. For example, imagine you have a physical box and you put a label on it that says age. Inside that box, you store the value 20. Later on in your program, whenever you need that age, you don't need to hunt for the number 20 again. Instead, you just look inside the age box and pull out the value. You can even change what's inside the box whenever you need to. It's super flexible. In summary, variables allow us to store, label, and reuse information dynamically in our programs. Let's see how variables look in Python. It's simpler than you might think. Check out this example. Age equals 20, but there's more to it. Here, age is what we call the variable name. It's like a label for a storage box. And 20 is the actual value that we are storing inside that box. Now, here's a key point. The equal sign here does not mean equals like it does in math. Instead, it represents the assignment operator, assigning a specific value to a variable. So, this whole line simply means, take the value 20 and store it inside the variable called age. Happy coding. Let's look at some more examples. Name equals Rahul. Price equals 99. Is student equals true. Here we have successfully created three distinct variables in our code. Name stores text, price stores a number, and is student stores a Boolean value. Variables help us keep track of different kinds of information in our program. When you're writing code, it's tempting to use short variable names like X or Y just to save a few keystrokes. But there's one important thing to remember. Variable names should always be meaningful. Take a look at this. If you see x equals 25 in the middle of a large script, you have no idea what X represents. Is it a coordinate, a count, or something else entirely? Now compare that to this. Age equals 25. Immediately, the code tells a story. You know exactly what that data represents without having to hunt for context. Meaningful names make your code significantly easier to read and understand, not just for others, but for your future self when you come back to it months later. Clean code starts with clear names, so next time you're naming a variable, think about the person reading it. Your future self will thank you. Let's talk about the essential rules for naming variables in Python to keep your code error-free. There are fundamental rules to follow. Understanding these will help you avoid syntax errors from the start. Rule 1. Variable names cannot start with a number. This is a common mistake for beginners. Rule 2. They cannot contain spaces. Use underscores or camel case instead. Rule 3. They can only contain letters, numbers, and underscores. This gives you plenty of flexibility. Valid examples include username with an underscore, age1, and total price. All perfectly fine. On the flip side, oneAge is invalid because it starts with a number, and username with a space will fail. Stick to these rules and you'll be writing great Python code in no time. Variables are the building blocks of programming, but their real power lies in their flexibility. Another useful thing about variables is that their values can change. Think of them as containers that can hold different data points. Example, we set score to 10, then later in the code we updated, score equals 20. Here the value of score was first 10 and later changed to 20. The program now remembers the most recent assignment. This is why they are called variables, because the value can vary during the program execution. Mastering this concept allows you to create dynamic, interactive software. You can also use variables in calculations. Example, a equals 10, b equals 5, and sum equals a plus b. Now the variable sum will store the result of adding a and b. So variables make programs dynamic and flexible. One common beginner mistake is forgetting quotes when storing text. Correct, name equals Rahulun with quotes. Incorrect, name equals Rahul without quotes. Text values must be inside quotes, otherwise Python will show an error. Now let's talk about data types. A data type tells Python what kind of data a variable is storing. Think of it like a label that defines what you can do with that data. Different types of data exist in programming, such as integers for numbers, strings for text, or booleans for true and false values. The best part? Python automatically detects the data type when you assign a value to a variable, making your code clean and efficient. In programming, one of the most fundamental and common data types you'll encounter is the integer. Put simply, integers are whole numbers. This means they do not have any decimals or fractional parts. Let's look at some everyday examples, like setting age to 25, tracking the year as 2024, or recording a score of 100. Whether positive or negative, as long as it's a whole number, it's classified as an integer in your code. The next data type is float. Floats are numbers that contain decimal points, allowing for greater precision. For example, while an integer can count whole items, a float is perfect for things like price. Here, price equals $19.99, or temperature 36.5. We also use them for ratings, like 4.8. So, whenever a number includes a decimal, Python treats it as a float, keeping your calculations accurate. Another very important data type you will encounter in programming is the string. Essentially, strings are used to represent text data in your programs. Take a look at these examples. Name equals Rahul, city equals Delhi, and message equals hello world. Crucially, strings must always be written inside single or double quotes to work correctly. Next is the Boolean data type. Boolean values represent true or false. Examples, is logged in equals true, and is admin equals false. These are often used in conditions and decision-making inside programs. Understanding Booleans is essential for controlling the flow and logic of your software. Sometimes when you're coding, you really need to check the data type of a variable to ensure your logic is correct. In Python, this is incredibly simple. We can use the built-in type function to find out the data type instantly. Let's look at a quick example. Here, we define the variable age as 25 and then print the result of the type function. This will tell us that the variable age is an integer. It's a simple tool that's essential for every Python developer. Now let's check another example of using the type function in Python. Suppose we define a variable name as Rahul and then print its type. The output will show that this variable is a string. This function is very useful when debugging or learning Python. Python automatically decides data types based on the value you assign. It's called dynamic typing, and it's a real time saver. Take the variable x equals 10. Because it's a whole number, Python instantly treats it as an integer. If you add a decimal, like y equals 10.5, Python recognizes this as a float data type. And for text in quotes, like z equals hello, Python handles it as a string. No manual declaration needed. Whether it's an integer, a float, or a string, it's all handled under the hood, making your code cleaner and easier to read. Understanding data types is fundamental in programming. Why? Because the type of data determines exactly what operations you can perform on it. Take numbers, for instance. You can perform arithmetic like addition or multiplication. 5 plus 5 equals 10. It's simple, direct, and predictable. But text, or what programmers call strings, behave quite differently than numbers, even if you use the same symbols. For example, if you try to add two words like hello and world, you don't get a mathematical sum. You get hello world joined together. This is called concatenation. If you try to add a number to a string without being careful, your program might crash or behave unexpectedly. Knowing your types is key to bug-free code. From integers to strings, data types are the essential building blocks of logic. Master these basics, and you're well on your way to mastering programming. Ever wondered how Python stores information? It uses data types. Let's explore the 4 essentials. First, we have integers. These are whole numbers, positive or negative, without any decimal points, perfect for counting things. Next are floats. These represent real numbers with a decimal point. You'll use these for precise values like prices or scientific measurements. Then we have strings. Any sequence of characters wrapped in quotes is a string. It can be a single word, a sentence, or even a line of code. Finally, Booleans. These represent logic and can only be one of 2 values, true or false. They are the switches of your program. Now you know the most important beginner data types in Python: integer, float, string, and Boolean. So in this video we learned what a programming language is, what Python is and why it is popular. Next we looked at how variables work and the basic data types in Python. In the next video, we will start writing real Python programs and learn about operators and input from users. If you found this helpful, make sure to like, subscribe, and follow Code with AI for more programming tutorials. See you in the next lesson.